Hey guys, now that we've got a web application up and running in our cluster here and everything looks to be pretty healthy here, let's go ahead and add in a liveness probe into our deployment spec here. So remember that a deployment spec in Kubernetes has an embedded pod spec. So under the template section right down here, this is where we can define all of the details for the actual pods in our deployment. And then the deployment basically just specifies the number of replicas that we want for that pod spec. So down under the pod spec here, we've got the containers child property that defines an array of containers. And in this particular deployment spec, we currently only have a single container. And what we want to do now is add in a liveness probe. So what I'm going to do is fire up the documentation for liveness probe so we can see the different options that we have available to run a liveness probe. So the first example that we're going to do here is actually how to create a command-based or shell-based liveness probe. And again, you can call whatever kind of HTTP client utility you want to in order to test this out, or if there's some other kind of automation test that you want to perform, feel free to do that. But I'm just going to use PowerShell itself to call that invoke web request command in order to ensure that we are able to access the web application in the local container. Because remember that this liveness probe is being executed locally against that container. So at the container level, you can see that we've got the container name, image, arguments, if applicable there. Of course, we built the entry point into our container image, so we didn't need to specify the arguments here. But then at the same level there, so it's at the container level, we have liveness probe, and that's going to be that exact value, liveness probe. So let's come back here and make sure we get the indentation correct under the container configuration right here. So we're going to indent to the same level as all of these other container level properties. We're going to add in the liveness probe attribute. Now you'll notice I got some IntelliSense there, or auto-completion from my editor, and that's because I am using Microsoft Visual Studio Code, which is an incredible open source cross-platform editor. And if you hit Control-Shift-X, or if you're on macOS, hit Command-Shift-X, and search for an extension for Kubernetes. And Microsoft actually has this extension right here called the Kubernetes extension. And if you install that, it will actually autocomplete certain values for you in your Kubernetes manifest files. And that just makes building manifest files in Kubernetes a lot easier. So now, under the liveness probe, we want to add in the exec section, and the exec is basically telling us that, or telling Kubernetes rather, that we want it to do a shell-based command in order to run a test. So back in our manifest here, we'll say exec. You can see we get completion there again, and then command is the child property we need to specify. And now right here is where we can specify what command we want to run. And so I'm going to call PowerShell. And then PowerShell uses the -command parameter to specify just a PowerShell command that you want to run after that. So it's kind of like an inline command at the shell. And then I'll say invoke web request -URI, and then we'll say HTTP localhost port 80. And again, it's just going to be running in the local container under port 80 here. So that's where our web application is exposed at. And we want to also add in /home. And so our expected command output here is going to return an HTTP status code of 200. And actually, in this case, we're running an exec, so we're expecting a 0 exit code in response. So if we were running the HTTP-based probe right here, this one looks a little bit different. This one would be looking for an HTTP 200. Or actually anywhere all the way up to 400, so more than 200 or less than 400. But since we're running the exec command, that one is actually going to use 0 exit code, as you can see right here in the documentation. So just keep in mind that if you're running a command-based, you want to make sure that you return exit code 0. And if you do experience any errors, you want to handle those inside of your command to ensure that you're getting the expected response code from that shell command. So back here in our liveness probe configuration, I think this looks pretty good. If we were to just run this like PowerShell, well, I can't run it on that virtual machine, but if I was to run it locally here, say PowerShell -command, and then invoke web request, that should basically return an exit code 0 if it is successful. But remember, we terminated the local container that we were running to test out our application. So in this case, we actually get an exit code of 1. So that actually failed, and we kind of expected that. However, if we do a Docker run here, so let me spin that up on port 34,000 once more. And then let's go ahead and try this command, but change the port to 34,000 just as a localized test here. We'll do that and change the port to 34,000. So this should return last exit code of 0. So you can kind of see that if it succeeds, it does return HTTP 200 and no errors, then it will show a last exit code of 0, which is exactly what we want for Kubernetes to consider them healthy. All right, so we'll save this manifest file here, and we'll select it, bring it back over onto my remote to virtual machine, and just edit this deployment. Let me do 1GG, and then 50DD to delete everything. And then I'll go ahead and do insert mode and paste this in. And now we've got our liveness probe in there right at the bottom. And now we'll do a kubectl apply -- file name and then deployment.yaml. All right, so now we've reconfigured that deployment. We didn't change the name of the deployment, so it basically just reconfigured the existing object on the Kubernetes API server. So now if we do a kubectl get pods, we should see that a new replica set was created because we actually changed something about our pod spec in the deployment manifest. And so that requires that Kubernetes deployment controllers actually create a new replica set that has the new pod configuration. And so that's what you can kind of see here in this prefix. So if we do kubectl get replica set, you can see that the old replica set has been changed to have 0 pods. And the new replica set that was just created a few seconds ago now has the 3 pods, and they're all in a ready state. So if we do kubectl and then say describe pod, actually let's do a get pod again really quick, and then we'll describe one of these specific pods right here. So I'll copy the name of one of those and say kubectl describe pod with that name. And as you can see right down here, it says that the liveness probe is actually failing here. So it downloaded the image and it said liveness probe failed, and it said container web server failed liveness probe, and it'll be restarted. And so what's happening here is it's actually killing off the container in the pod, and it's restarting the web server every single time. And it looks like that liveness probe is just continually failing here. And so what we'll need to do is kind of figure out why that's happening. Now, the pod web server does actually take a little bit of time in order to spin up, and so one of the additional properties that we can add into our liveness probe configuration is this property called initial delay in seconds. And so we can give the pod web server a few seconds to start up before the liveness probe starts actually pinging the service. So let's add in the initial delay seconds of maybe 5 or 10 seconds. And then you can also set the period in seconds for the liveness probe as well. So this is how often the liveness probe will be executed. So back over here on my remote server, I'm going to go ahead and run vim on our manifest file here. And then I'll go down all the way to the bottom. And on this liveness probe, we want to make sure we're indented the same level as the exec property here. And then right there, we'll go ahead and add initial delay seconds. And we'll set that to, let's say 5. Well, let's do it 6 just to be safe. And then we'll also add in period seconds. And we'll set that to, how about 5? All right, so we'll go ahead and save that. And then we'll do another kubectl apply on that file name. And that's going to create yet another replica set. So we'll do kubectl get replica set. And here's our new replica set right here. And it looks like it is spinning up. So now we'll do kubectl get pod. And let's grab one of these pods and just see if that fixed it. So we'll do a kubectl describe pod with that name. And it looks like that liveness probe is still failing initially there. So let's go ahead and see what's happening here. There's a couple of other features that you can configure on probes as well. One of those is the failure threshold. And by default, this is the number of times that the probe can fail before the pod is marked as unhealthy or the container is marked as unhealthy, and Kubernetes will restart it. Now the default values of that is 3. So if you think about the number of seconds that the probe is running, which I believe is set to 5 right now. So we have an initial delay of 10 seconds and a period of 5 seconds. However, on top of that, we've also got the failure threshold of defaulting to 3 because we haven't specified that value. And so that's going to give us basically 15 seconds approximately to check the health. So that's probably fine for our use case here. But the other thing that I wanted to draw your attention to right here is the timeout in seconds. And PowerShell is not the fastest at starting up. And so it's very possible that because the default is 1 second for the timeout seconds for the probe, we may need to increase that a couple of seconds to ensure that the probe has enough time to actually execute. Otherwise, Kubernetes is just going to terminate the probe and it'll just mark it as unhealthy. So let's add in the timeout seconds and see if that fixes things. So I'll add in another property into our deployment manifest here, and we'll say timeout seconds, and let's set it to 4 just to make sure that it has a couple of extra seconds to initialize PowerShell and run the invoke web request command. So I'll run that, and then we'll go ahead and do a kubectl apply again. So let me just search for that, and we'll reapply our deployment manifest, and that's going to create a new replica set. So let's just do kubectl get pod again here. And in a moment, we should have an entirely new replica set up and running here. Got an ID of 8486. And so let's give this a few seconds to see what happens. And I'm going to do a kubectl describe pod on just one of these pod IDs right here. And we're going to be looking for that liveness probe to basically start succeeding here. Remember that we have a 10-second initial execution period where that liveness probe is not going to fail, but then we're going to start running it every 5 seconds. And you can see that that liveness probe is configured right up here. We have a failure threshold of 3. We have a period of 5 seconds. And right now we have a success of 1. And so let me just run this again and see what we've got here. And so it looks like this is still actually healthy here. So we may have actually fixed this by increasing the timeout period of the probe. So you'll want to be thinking about the command that you're actually using in order to run the probe, and just make sure that your timeout seconds is set high enough to accommodate that command. Do just keep in mind that the default timeout is 1 second, and so if that command doesn't run pretty much instantaneously, then the probe could potentially fail. And that's really important, especially if you have a custom endpoint that is testing external resources. So if your health endpoint is testing, access to Redis or access to MySQL or other external services outside of the cluster even, that introduces latency into the probe. And so therefore your timeout seconds would need to be increased in order to accommodate that. I hope this has been informative for you, and I'd like to thank you for viewing.